and I can post it on YouTube. All right, so I know you can't see what I have written here, but I know that you have it in front of you. So the patient has ordered dopamine infusion to begin at 5 micrograms per kilogram per minute. Is that the same question we're looking at?
Yes.
Okay. Patient weighs 70 kilograms. Dopamine available is 400 milligrams per 250 ml. And then what rate should the nurse begin the infusion? So this is a multi-step problem. The first thing is I always start off, and this is just my strategy with these types of questions, account for the patient's weight. So we already know that they're 70 kilograms. If this question had given it to you in pounds, you would just convert the pounds to kilograms. Then you're going to multiply by the 5 micrograms and then the kilogram minute. When you do that, you get 350 micrograms per minute. Now, the next piece of information they give us is that we have 400 milligrams per 250 ml. So we have 2 separate units. We have micrograms and we have milligrams. So we're going to need to do some converting. We also need to convert minutes to hours. So we need to do all that. So you can, you have to convert micrograms to milligrams, or you have to convert milligrams to micrograms first before you move forward with solving the problem. And you can convert minutes to hours now, or you can do it at the end. I'm just going to go ahead and do it at the end, just because that's how I've been doing it. So, but I just want you to know, if you did it differently, but got the same answer or the right answer, you're doing it right. Okay. So all I'm going to do is, I'm not going to show the dimensional analysis for this, because all I would do is move my decimal 3 to the left when I'm going from micrograms to milligrams. So I would get 0.35 milligrams per minute. Okay. And if I say something that's confusing, just stop me and say, wait, how'd you do that? And can you show it this way? Just stop me and I will show you whatever way you would like to see it done.
Okay, thank you.
You're welcome. All right, so I have 0.35 milligrams per minute. And then what I'm going to do is I'm going to get, all right, I need to get rid of these milligrams and get us into volume over time, since that's what we're looking for ultimately, is the infusion, the flow rate in milliliters per hour. I don't think it clarifies what flow rate to begin, but unless it says drop rate is drops per minute, flow rate is milliliters per hour. Okay. So I do have a way to get from milliliters from milligrams, and that's the available is the 400 milligrams and the 250 ml. What that does is eliminates milligrams, 250 times 0.35 equals 87.5 divided by 400. And then you get this funky decimal of 0.21875 milliliters per minute, which would be great if that's all we were looking for. But we're going to convert minutes to hours. Like I said, I did this last. You could have done this up here if you had wanted to, and then had this as, 60 times 0.35, and then you would have been in milligrams per hour. So either way you do this, you're going to come up with the same answer. So I don't want you to think otherwise. So when I do the 0.21875 times 60, I get 13.125 milliliters per hour. And I believe that is what the key says, but you should be rounding to the nearest tenth. So I would say you should put 13.1 milliliters per hour as your final answer. I think if you write both, you can at least show and justify your answer. But like I said, I know that the key says 13.125, but you should be rounding to the nearest tenth.
That was helpful to see, because you left the 0.21875 and you didn't do anything to it. And that's what I was doing.
Were you rounding it?
Yes.
Yeah, don't round until the very end, until you're all done. And so the way to kind of circumvent that is if you had did this step here, you wouldn't have had to worry about that. You wouldn't have had this funky number because you would have already taken 60 times 0.35.
Okay. Yeah, that makes sense.
All right, I believe there was a second question.
Yeah, the other one I was asking about is number 25, part C.
Okay. C, both parts?
Yeah.
Okay. I'm just making sure it's the same thing. It's the heparin protocol. Now that, so you were okay with parts A and B?
Yeah, I got both of those.
Okay. Let me ask you, so this is, I actually blew this one up because this is the one we cover in third and fourth semester. So tell me what you did and where you're getting stuck so I know how best to help you.
So I have, for I guess the first part, I have 50 kilograms times 40 units equals 2,000 units.
Mhm.
And then I have the 2,000 units times 1 ml over 1,000 mLs equals 2 mLs for the answer for number one. So I guess I'm really just stuck on part C, the second part,
Okay.
the new infusion rate.
So you did, I just want you to know you did part one perfectly. So
Okay.
That's exactly what I do. So tell me what you have tried for two.
I honestly just didn't even know where to start.
Okay, good. That's fine. I appreciate the honesty because it lets me know where to start. So you know, the thing says that after we take, or part C says, well, we look at the APTT after 6 hours and it's 43 seconds. And we go to step 12 in the protocol. And that's where that range is. You did the first part, the rebolus. The second part is calculating the new infusion rate. So you can see that it says to increase the rate by 2 units per kilogram per hour. So we're increasing by 2. What was our original? Our original bolus was 80 units per kilogram. Our original drip was 18 units per kilogram per hour. So 18 increased by 2
is 20.
You got it. So then now that you've done that, you're going to set it up the exact same way you set up B. So try that out and let me know if you get the right answer.
Okay.
Which is 10.
Yeah, that's exactly what I got.
Good. And then you might find this helpful as well, because I've done this a couple of times. So the only thing I can change on this problem, so on your test, if you remember this from last semester, you either got A and B or you got the C1, C2. Okay. So you won't get all 4 for this question. And then I created like a shorthand. Basically, all you need to do is once you find the patient's weight in kilograms, for part A, multiply by 80, divide by 1,000. You're going to do that every single time because that's what the protocol is a standard and we don't have any other protocol that we're following. So that's what we're using for the heparin protocol. For the initial IV infusion rate, you're going to take the patient's weight in kilograms, whatever that happens to be, times 18 divided by 100. Every time you do a bolus dosage strength, make sure you're dividing by 1,000. And every time you're calculating an infusion rate, milliliters per hour, make sure you're dividing by 100. So these are just a shorthand of what you did lengthwise or longwise up at the top. Same thing goes for the sections or the C part 1 and part 2. Really, if they're using my test, I'm always going to use that step 12 in the heparin protocol because it tells you to do 2 different things. It tells you to rebolus and it tells you to increase the rate. The other ones don't tell you to do both things. So most likely I'm always going to use that. The only thing that's going to differ is the patient's weight in kilograms. So part C1, multiply by 40, divide by 1,000 because it's a bolus dose calculation. And then C2, patient's weight in kilograms times 20 divided by 100. And so that way, if you challenge yourself and you try different weights, then you can just see what you get, and you can literally just plug it into here. I mean, still do this work because it's probably good at practice to show, the steps and working that out. But this is the shorthand if you just want to make sure you got, the same answer, both ways. And then just remember to round your final answer to the nearest tenth. And then when you do your initial converting pounds to kilograms, make sure you convert that to the nearest tenth as well. But if you wait and do the rounding to the nearest tenth at the end, it shouldn't change your answer too much.
Okay, that was helpful.
Good.
Mhm. Yeah, no, that was good because sometimes after you've run a problem, it's nice to be able to have a short way to check it. So having that shorthand answer is very helpful. So appreciate that.
Yeah, you're welcome. I don't remember who asked for it, but somebody was just like on me. It's like, what's just the numbers? And I was like, oh, I guess it's just this. And it is. So
Nice.
All right, well, thank you.
For number 11, I just want to make sure we're on the same one. So patient has congestive heart failure. They're ordered furosemide 200 milligrams IV daily. Available is furosemide 100 milligrams IV. The label reads furosemide 30 milligrams per milliliter. How many milliliters of the drug will you give? That's the same question.
Correct.
Okay, so tell me what you did.
So I started off just trying to set it up at, in a way that I could answer it. So I put 200 milligram IV daily, and then I put 100 milligram underneath that. Then I was confused on what to do with the 30 milligram over ml. I think I just didn't know how to set that up.
Sure. All right. So this is one of those problems that it has extra information that you don't need to know.
So there's a distractor.
Yes.
Yeah, gotcha.
And the distractor is the one you used. The one you needed, you didn't use.
Okay, that would answer that then.
Yeah. So think about when you've seen these types of problems before, you need to go from what is ordered to milliliters. So the two pieces of information that tell me that. So the ordered is the 200 milligrams. And then how do I convert milligrams to milliliters? That is right there. So what this is actually telling you is that in the pharmacy, it came in as it was 100 milligrams of powder. They added water. And then when they did that, they got 30 milligrams per milliliter as their concentration. And so this is just extra information, the 100 milligrams. That just tells you, how much powder is there, but you need to know what the dilution factor is, for lack of a better term.
Right. So like what I was saying was I definitely overthought it. I just was trying to incorporate all that information when I didn't need to.
Correct. No, and that's
okay.
And it's good to see that because you will see things like this on the test. Now, sometimes this is written out as furosemide, like 100 milliliter IV. And again, that you don't need to worry about that. You need to know how to get from milligrams to milliliters.
Right.
Yeah.
Okay. So then I would just set it up with 30 milligrams over ml. And then I would do yes.
You got it. You started with the ml over 30 and then times 200. We're doing the same thing. So
right. Work the problem and that's the answer. I knew it was very simple. So that's why I was like, I just need to step back and take a break and look at it.
Yeah, that's sometimes you want to use everything that's there. There's even a question in the 230 packet that it tells you the patient's weight, but you don't need the patient's weight to answer the question. So it's a distractor. It's just there. I tell them it's like the patient was also wearing a red shirt and purple shoes, and they're 6 feet tall. None of that matters for answering the question. It's just you just use what you need to answer the question. But I know that that's why they're called distractors, right? So
yeah, no, that was a good explanation. I appreciate that. Well, then that's basically it for me because you answered the question about the heparin drip,